let's take a look at 14.2. It is about speed, frequency, and wavelength. So just now we talked about a few things already. Number one, we talk about what is exactly a wavelength. A wavelength is basically the distance between the two successive peak or successive trough, or you can say it's a crest. That's wavelength. And then we talk about just now is frequency, as well as one more we call it as a period, correct? And then let me just bring it up again, the formula. The formula for frequency is 1 over T. The formula for period is 1 over F. And then the unit for wavelength is in meter. The unit for frequency is in hertz. And the unit for period is in second. Now it's time to combine 1, 2, and 3 components together. And that formula, in order for us to calculate the speed of the wave. In order for us to calculate the speed of the wave, we know that in terms of the wave, there is a specific direction, correct? Whenever there's a specific direction, we don't use the word s. In physics, what is the speed that we are using? What is the symbol we are using? We always use speed, velocity, yes. And the unit for velocity is always meter per second. Or you can say ms -1, either one. So what is the formula that group them together is basically the formula is V equal to F times lambda. This is the formula that we will be using like all the time. This is stand for the velocity of wave, because we know wave has specific direction. This is stand for our frequency, and this is stand for our lambda. We pronounce it as lambda, but it is representing our wavelength. Okay, so unit meter per second, hertz, and this is in meter. So how do we utilize this, people? Every single time whenever you want to use a formula, you always need to identify what is the information given to us. Because sometimes they give us a wavelength, they give us the period, they want us to find the speed. Of course, we can use the period formula to find the frequency, correct? Then only I put it back into here and calculate the velocity of the wave. For example, let me just run through like 2 short examples. Like let's say, for example, if they give us that there is this signal wavelength, let's say the FM radio, they give us that the wavelength. They give us that the wavelength it is equivalent to 1.5 meter. And then they tell us that the frequency it is equivalent to 200 megahertz. They want us to calculate what is the velocity of wave. So first thing, always identify. Whenever you're doing any calculation of physics, always identify what we have. What is this wavelength 1.5 meter? It means that I can say that right now my lambda equal to 1.5 meter, correct? Then our frequency is 200 megahertz. So if this frequency is 200 megahertz, logically thinking, can we use megahertz in our frequency? No, I have to convert it into a hertz. So megahertz is 10 power of what? Do you guys remember? Okay. The megahertz, always remember, it is equivalent 10 power of 6. That means that I can convert this frequency into 200 times 10 power of 6 hertz. Okay. Then we always standardize it. So if I want to standardize it, I can make it become 2 times 10 power of 8 hertz. Can follow me so far? Then only now we put in the things that we have into the question, into the equations. Based on our formula, V equal to F lambda. So I can say V equal to F lambda. And if I want to find the velocity, I can say velocity equal to frequency is 2 times 10 power of 8 multiplied by lambda is 1.5. So your final answer it is equivalent to 3 times 10 power of 8 meter per second. So every single time when you do it, identify what you have, then only apply the formula in. And that's it. That's how we calculate. Yes.
That's like Matt's really did.
Mm.
Did you change it to from 200 to 2 because it has to be less than 10?
Yes, you're right. In the standard form, yes. Yeah, people can. All right, people. Now, one thing I need to point it out. Familiar with this? Familiar or not? This number. 3 times 10 power of 8. What number is this? This is the speed of. This is a specific number for, we call that as a speed of light. Speed of light is always in 3 times 10 power of 8. Therefore, all the signals, all the radio FM signals, our visible light, our ultraviolet, gamma ray, all of them can travel in the speed of light. So you need to like get used to this number. You will see this a lot of times. Okay, Kham? Let me give you another example. Yeah, let's try another example. So this will be example number 1. Let's try example number 2. If it is in an example number 2, and then imagine that it is playing piano, and then the piano gives us the information which is it tells us that the frequency you're playing is somewhere around 4,186 hertz. And then they give us that the sound in the air. Sound in the air is about 330 meters per second. The question asked us is, find the wavelength. So in order for us to find the wavelength, always identify frequency is this, got no problem. Sound in the air, velocity, got no problem. So put in all the things into the formula. V equal to F lambda. My velocity, it is 330. Equal to frequency is 4186 multiply lambda. So if I want to find lambda, it will be 330 divided by 4186. So your lambda will be equivalent to . So it will be 0.079 meter. Usually when you want to standardize like every single number, did I do anything? 4186, right? 46. Yeah, 0.079. Yeah. Usually if you want to standardize like any number in physics, right? You can always standardize it to become 2 significant figures. Okay. So yeah, that's how we use the formula, and that's how we apply that into the questions. Okay. I will stop recording, take a photo, and send it. This is just 14.2 done. Later after this, we do 14.3. We do a lot of drawing. All right. Anything to ask?
How do you pronounce that one?